Alright, this is the video lesson for Unit 3-1, solving one-step equations and inequalities by adding and subtracting. So go ahead and turn in your notes packet to the first section here of Unit 3 and read through these first 3 bullet points with me here, making sure you understand a little bit about equations and inequalities. So first of all, to solve an equation or an inequality means to find all of the values of the variable that make the equation or inequalities true. Remember, you may have more than one answer, especially when talking about inequalities. Also, when we solve, we are trying to get the variable by itself so we know what the variable is equal to, obviously. And then the third bullet point here, we solve equations and inequalities by doing the opposite of what is being done to the variable. That one right there is probably the most important as far as learning how to actually solve these. You have to do the opposite of what is being done to the variable. So when I go through these examples, I'll be mentioning that specifically. So let's go ahead and start here with example 1. And again, I'm going to refer back to that highlighted sentence very often here. So first thing I'm going to ask you in example number 1 is, where is your variable? First of all, well, you'll say right there's my variable, it's m. My variable is m, and I would then ask you what is being done to your variable, and hopefully you would be able to tell me that it is being subtracted by 48. You are taking 48 away from m. m minus 48. So what is being done to the variable is that you are subtracting, it is being subtracted by 48. Well, you then have to, based on what it says in this, you have to do the opposite of what's being done to the variable. Well, the opposite of subtracting 48 would be to add 48. So what you now need to do is you need to add 48 to both sides of this equation. And when I say both sides, I am referring to sides of the equal sign. Left side of the equal sign, right side of the equal sign. You always have to keep your equations balanced. And in order to keep them balanced, you have to do the same thing to the left side of the equal sign as you do to the right side of the equal sign. So here we go. We have just added 48 to both sides, and now you actually do this math. You say right here, negative 48 plus 48, well, that's 0, so it's gone. 0. So all you have left on the left side is the variable m. The equal sign is in the middle and will always stay right there in the middle. And then on the right side, you simply have the basic addition problem here, negative 29 plus 48. And again, as I've told you before, you can use your calculators, that's fine. Type in negative 29 plus 48 and you get 19. So in other words, our answer is m equals 19. m is 19, and you can always check this answer, and I will not necessarily make you do this all the time, but you can always check your answer by simply plugging that answer back into the original problem. If m is 19, and my original problem said m minus 48 equals negative 29, you plug that m, or that 19, in for m and say 19 minus 48 equals negative 29, and then check that. Does 19 minus 48 equal negative 29? And it does. So yes, that checks out. You must have done the problem right. The answer is m equals 19. Alright, so example 2 is the exact same type of problem, but it looks different because the variable and the number are kind of out of order. But again, you've got to understand what is happening to your variable. This equation says negative 67 plus x equals negative 5. Negative 67 plus x. Well, what is happening to your x is it is actually being subtracted by 67. That's what the minus 67 is. This is a positive 1x, and what's happening to it is you're subtracting 67. Another way you could write this equation is you could say, okay, I have a positive 1x, and I have a minus 67 that equals negative 5. So you're saying x minus 67. These two things are the same equation. They're just written in different orders. Bottom line is, is that the way you solve this is you, again, do the opposite of what's happening. So if you are minusing 67 to your x, you need to add 67 to both sides. The negative 67 and the positive 67 cancel out and become 0, so it's gone because there's 0. You're left with your x here on the left side of the equation, and on the right side of the equation you simply have negative 5 plus 67, which leaves you with a positive 62. Final answer, one-step equations. In both of these examples I had to add something to both sides to balance the equation. Alright, so that is the first two examples. Let's move on now to the examples 3, 4, 5, and 6. Okay, so let's look at these examples right here. Alright, now, a couple of things about these examples that you're going to notice that are slightly different. One thing here on number 3 is you have what I like to call a double sign. Anytime you see a double sign, meaning that you have two signs right next to each other with no other numbers in between each other. A lot of times there'll be a parentheses there like I've shown here. You're not really ever supposed to have a double sign. Most people have probably learned at one point or another that subtraction, if I say 10 minus 2, a lot of people have learned that you can rewrite subtraction as add the opposite. Well, now you've created a double sign. You have 10 plus negative 2. Again, we don't really like that in math. We would rather leave that as just 10 minus 2 and not use that double sign. So in this first example, where we have the minus a minus, hopefully everybody remembers that anytime you have subtract a negative turns into plus a positive. So what I actually like to do with this double negative is just turn it into one big plus sign, and I'm just going to write right over that and make that one big plus sign. So now I have 12 plus y equals 7. 12 plus y equals 7. Well, again, what is happening to your y? Well, it's being added by a positive 12. Again, another way to think of this problem is you could actually rewrite this problem and turn the y and the positive 12 around, and now it says y plus 12. These two things mean the same. You are adding 12 to your y to equal 7. What plus 12 equals 7? So to figure that out, you need to do the opposite of what's being done to your y. So the opposite of an adding 12 is a minusing 12. So I'm going to subtract 12 on both sides. Again, positive 12 and negative 12 cancel out, and you're left with y equals 7 minus 12 would be negative 5. Final answer. Y equals negative 5. Again, check that if you want. 12 minus 5 in this problem up here, in the original problem, 12, and then if y is negative 5, it would say 12 minus 5 equals 7. Well, yes, 12 minus 5 does equal 7, so that checks out. Okay, over here with example number 4, again, you have a double sign here. You have a plus, a minus, plus, a negative. But again, all plus a negative really means, if you go back up here and think about my example here, plus a negative is just subtraction. So this problem really is just m minus 3.42 equals negative 6.91. Now this would be an example of where your calculator is going to be helpful here because you have some decimals. But again, I'm going to ask you every time when we're doing these problems, I'm going to ask you what is happening to your variable. What is happening to your variable? And in this case, what is happening to your variable is it is being subtracted by 3.42. Well, what's the opposite of subtracting by 3.42? That's right, adding by 3.42. So add 3.42 to both sides and then solve. Again, the positive 3.42 and the negative 3.42 will always cancel out. That's what they're supposed to do. So you're left with just your variable, m equals. And then again, this will probably be a good time to use your calculator. You have negative 6.91 minus, no, not minus, sorry, plus 3.42, and you're left with a negative 3.49. M equals negative 3.49. And again, you can check that does negative 3.49 plus negative 3.42 equal negative 6.91? Yes, it does. All right, let's look at number 5. Number 5 is pretty much the same exact problem as number 3. We have that double negative again. I want to change that. I don't want minus a minus. Minus a minus just turns into a plus. So I now ask the question, what is happening to my variable? Well, x is being added. You're adding a 3.2 to your x. So you have to do the opposite of that, which is subtract 3.2 on both sides. On both sides of the equal sign here, subtract 3.2. X equals, and then again check what is 15.7 minus 3.2, 12.5. Very good. All right, fractions. Now again, remember, well, don't remember, I'm telling you this for the first time. Problem number 6 here. Sometimes the computer won't type out a fraction out very good, but 5/9 means 5/9. So 5/9 equals k minus 3/5. Again, hopefully you all have your scientific calculators by now, so you can do fractions on your calculator. Because again, the process here is going to be the exact same. I'm going to ask, what is happening to my variable? There's my k. What's happening to it? It's being subtracted by 3/5. What's the opposite of subtracting by 3/5? Well, that would be adding 3/5. So you add 3/5 to both sides. Negative 3/5 plus 3/5 cancel. I'm left with my k over here, which is fine. It doesn't really matter what side your variable is left on. And then on the left side, again, get out your fraction calculators. Take 5/9, and you're going to add 3/5, and you'll get your answer. And again, I don't really care which way you write your answer. You can write your answer in improper form, which would be 52/45, and leave that as your answer. Or you can change 52/45 into 1 7/45. But again, that's just simply calculator work. We're not learning how to use fractions or do fractions right now. Get yourself a fraction calculator. We're talking about the algebra at this point. So again, that is adding and subtracting to solve equations. Nothing tricky there. You do the opposite of what's being done to the variable. Always find your variable, figure out what's being done to it, and then do the opposite of that. Okay? All right, well then let's now discuss inequalities. Now, the nice thing about inequalities is it's going to be the exact same as equations as of now. First of all, make sure we understand our signs. So right here, on your notes page, just make sure you understand what is a less than sign, what is a greater than sign, what's a less than or equal to, what's a greater than or equal to, because that will be very important when we get to the graphing part of this, because we are going to graph these. We are going to graph these. So let's talk about this example number 1 here at the bottom of the page, and then we'll talk about the last 2 examples in a minute. At the bottom of the page here, we have x plus 5 is, and again, check your signs here. This one right here would be a greater than sign. So x plus 5 is greater than 12. So what plus 5 is going to be greater than 12? Well, a lot of things plus 5 are going to be greater than 12, so we want to find them all. So again, to solve this, you're simply going to do the opposite of what's happening to your variable. Here's my variable. What's happening to it is it's being added by 5. What is the opposite of adding 5? Well, that's minusing 5. So you're going to minus 5 on both sides. And again, when I say both sides, I mean both sides of the equal sign, or in this case, inequality sign. 5 minus 5 is 0, so I'm left with x is greater than. The greater than sign stays right in the middle there. And then 12 minus 5 is 7. So that's my answer. X is greater than 7. So any number greater than 7 is going to when you add 5 to it, be bigger than 12. Now, when I say any number, I don't just mean whole numbers. I mean if 7.1 is bigger than 7, right? So 7.1 plus 5 is going to be greater than 12, because 7.1 plus 5 is 12.1, and 12.1 is greater than 12. So we're going to graph this now, and when you graph it, I want you to graph everything that makes this true. So on your graph, I want you to draw a number line. I want you to use at the very least 5 points. In this case, I'm going to use probably more than 5. And you want to start somewhere close to the number that you've got. So since I got 7 as my answer, greater than 7, I'm going to kind of start in here somewhere with 7. So I'm going to do 7 right here. And then I'm going to count up 8, 9, 10, 11, and I'm going to count down 6, 5, 4. So I'm going to do 4, 5, 6, 7, 8, 9, 10, 11. And again, I want at least 5 numbers on your number line. Sometimes you'll want to do more just to show it better, but here's how we graph x is greater than 7. All right, so I'm going to come back up to our notes here at the top, and I'm going to use some examples. So if the inequality says less than, you are going to draw an open circle and you're going to shade everything to the left, because left is where the smaller numbers are, the less than numbers. If you're going to graph a greater than, you're going to draw an open circle and you're going to graph to the right, because that's where the greater numbers are. Now, why do we use an open circle, which is what we'll use here in this problem? X is greater than 7, so I'm going to draw an open circle on 7, and I'm going to graph everything to the right, or everything that is bigger than 7. What is bigger than 7? Well, 8's bigger than 7. 9's bigger than 7. 10's bigger than 7. 11's bigger than 7. But also, 7.1 is bigger than 7. 8.2 is bigger than 7. So that's why we shade this in. So you count all of those points will make this inequality true. Now, why do we put an open circle? Is because are we going to use 7 itself? And the answer is no. 7 plus 5 is greater than 12. 7 plus 5 is 12. 12 is not greater than 12. 12 is not greater than itself. It is greater than or equal to, because it is equal to 12, but we're not doing that right now. We're doing just greater than. So the open circle implies that I want to include everything. I'm not going to include 7, but I'm going to include everything bigger than 7. Even 7.1, even 7.000001. But the open circle means I'm not going to include it. Now, if this equation had said less than or equal to, with the little line underneath the less than sign, or greater than or equal to, in that case, you draw a closed circle. Closed circle to the left for less than or equal to. Closed circle to the right for greater than or equal to. Because then the closed circle is telling you that, yes, I am going to include that number and everything bigger than that number. So if this was a closed circle on 7, it would say I want 7 and everything bigger than 7. So that's how you do inequalities, and that's how you graph them. Not too tricky. Understand when you use an open circle and when you use a closed circle. Understand which one is greater than, which one is less than, so you know which way to shade. All right, so we're going to look here at our last couple examples, and I'm going to let you get started on some practice problems here. Maybe here. Let's see if I can scroll down here. All right, so I gave you some helpful hints here for graphing and shading, and I'll let you read through these yourself. I've kind of already mentioned all of these. I just have this in here again as a reminder to help you out on your own, so read through those. Use those as good notes here. So let's go ahead and do these last two examples. In number 8, again, I asked myself, what's happening to my variable? There's my variable. What's happening to it? I'm adding 30. So I'm going to do the opposite of adding 30, which would be subtracting 30. And the positive 30 and the negative 30 cancel. I'm left with A is less than or equal to. That's what that sign is, less than or equal to. And then 11 minus 30 is negative 19. and I'm going to graph it. So again, I'm going to draw my number line. Now be careful when you're graphing negatives. If negative 19 is the number I got, and I'm going to put that kind of here in the middle, make sure you know which numbers are bigger than negative 19 and which numbers are smaller than negative 19. Bigger than negative 19 would be negative 18, negative 17, negative 16. Smaller than negative 19 would be negative 20 and negative 21. Okay? So make sure your number line is always going the correct way. Make sure your number line is always correct. Now, as far as graphing and shading, it is a less than or equal to. So I am going to color my circle in here on negative 19, and then less than means I want all numbers smaller than that. So that's everything shaded this way. Okay? Alright, very good. And last problem. Here's my variable A. What's happening to A? Well, it's being subtracted by 76. So I'm going to do the opposite of subtracting 76. I'm going to add 76 to both sides. Positive 76 and negative 76 cancel. So I have A is less than, and then I do negative 30 plus 76, and I get positive 46. So now I'm going to graph this. So again, right here in the middle somewhere, I'm going to put my 46, then 47, 48, 49, and then the other way, 45, 44, 43. So, again, this is a less than now, so it's going to be an open circle on 46 and graphed left, or all the smaller numbers, all the less than numbers. Alright, so there you have it. There is your solving equations and inequalities using adding and subtracting, along with graphing of the inequalities. Good luck on your practice problems.